Okay, graph quadratics using the x-intercept. So let's take a look at 6.3. The x-intercepts of some quadratic relations given in the standard form can be found by factoring. Okay, so we've done that already. To find the x-intercept, set y equals to 0 in the quadratic relation and solve the resulting quadratic equation for x. So what we want to do for example 1, find the x-intercepts of this quadratic relation. So we want to sub y equals 0. Okay, and then all we want to do is factor. So in order to factor, so we factored with expressions, and now this is an equation. The difference is an equation has an equal sign. So now all we have to do is product sum. So what two numbers multiply to 7 and add to 8? Well, it's 7 and 1. So I get 0 equals x plus 1 in brackets and then x plus 7. So to take it one step further, we're going to find the x-intercepts. So we're going to branch each of these off. X plus 1 equals 0. And we're going to branch this factor off. X plus 7 equals 0. And we're just going to rearrange. So x equals -1. X equals -7. Those are the two x-intercepts. Okay, now B, sketch the graph by plotting the x-intercepts in the vertex. Okay, so again, the x-intercepts were -7 and -1. So we can go ahead and plot those. Okay, and then the equation of the axis of symmetry. So the axis of symmetry, it would be the average of the x-intercepts. So we just add -1 plus -7, and then we divide it by 2. So I get -4. Okay, so even when we're looking at this graph, it should be right in the middle. So 1, 2, 3, 1, 2, 3. Okay, now the vertex, we take that -4 and we plug it back into the equation. Okay, so you can sub it into the expanded equation or the factored equation, whichever one you want. So for example, the factored equation would be -4 plus 7, which is 3, times -4 plus 1, which is -3, which is -9. So the vertex occurs at -4 and then -9. Here we go. Okay, and direction of opening, this definitely opens up. We can see that from the A value, like that, the leading coefficient, or we can just see that by these 3 points. And then at the end, you can go ahead and you can label this y equals x squared plus 8x plus 7. Let's recall the y-intercept of a quadratic equation in standard form, so expanded form here, is c. So this point right here. So the point is 0, c. Okay, example 2. Find the x-intercepts of this quadratic relation. So let's go y equals -x squared plus 6x minus 9. So in order to start this, we're going to set it equal to 0, and I'm going to actually start it already. So I'm going to common factor out a -1. Okay, so I get -x squared minus 6x plus 9. So this is where we can start because this leading coefficient is +1. Okay, you always want it to be positive. So with product sum, what two numbers multiply to 9 and add to -6? Okay, so for 9, we get 1 and 9, 3 and 3. So it's definitely 3 and 3, and we could put a negative sign on each of those. So x minus 3x minus 3. Okay, in other words, we can rewrite this as 0 equals -x minus 3 squared. For the x-intercepts, when we have one factor repeated here, so a factor squared, we're still going to set it equal to 0, bring the -3 over, we get x equals 3. But what this is going to look like is this opens down. The vertex is going to lie right on the x-axis. Okay, so part B asks us, sketch the graph of the quadratic relation. Okay, and, oh, it's repeated. of this equation using the x-intercepts and vertex. So we already know what the x-intercept is. So again, it's x equals 3. Okay, but there's only one. So we're going to go ahead and plot that. Now, what's the equation of the axis of symmetry? Well, it is x equals 3. If you want to do that algebraically, it would be like 3 plus 3 divided by 2, which is 6 over 2, which again is 3. So we get this x equals 3 as the axis of symmetry. Okay, so we can't actually graph any other points just by this. And if we take a look at the vertex, let me just scroll up, okay, even if we sub in that 3, y equals negative 3 squared plus 6 times negative 3 minus 9, and we get negative 9 minus 18 minus 9. You're positive. Okay, and that would equal 0. So for the vertex, again, we're getting 3, 0. So we can't really use this method if the vertex lies right on the x-axis. So instead, why don't we actually go ahead and solve for the y-intercept? Okay, and as a review, if we sub in 0 squared plus 6 times 0, that goes away, and we get the y-intercept equals negative 9. So now let's take a look at symmetry here. Okay, so y-intercept is negative 9. This is 3 units away from the axis of symmetry. So let's go another 3 units. So we're going to go from 3 to 4, 3, 4, 5, 6. And we can go ahead and plot another point at this negative 9. If you want to go ahead and sub that in, you can. Or you can just use symmetry, because it's symmetric about the axis of symmetry. Okay, and this opens down. So a little bit of a different approach if the vertex lies right on the x-axis. Example 3. Find the equation of the parabola in standard form with zeros negative 1 and 7 and passing through this point. So we saw a question like this before. We're not able to actually start with standard form. If we're given zeros, what we want to do is we want to start with this factored form. Okay, so here's your hint. Find the equation of the parabola in factored form first, then change the equation of the parabola to standard form by expanding and simplifying. So we're going to go ahead and go y equals, we need our a. That's usually what we want to solve for, is our stretch or compression. So then x plus 1, x minus 7. Okay, and then let's go ahead and sub in 3, 5 for the x comma y. So 5 equals a, 3 plus 1, and then 3 minus 7. 5 equals a, 4, and then negative 4, which gives us negative 16, a, and then we can divide both sides by negative 16. Okay, therefore, the equation in factored form is negative 5 over 16, and then we have x plus 1, x minus 7. Okay, the original question asks for us to express this in standard form. So let's go ahead and FOIL these two brackets. We'll still leave the negative 5 over 16 outside of the bracket. And now we have x squared minus 7x plus x minus 7. Let's simplify those two terms in the middle by just collecting them. So negative 7 plus 1 is negative 6. And now we can go ahead and expand this negative 5 over 16 into the bracket. So we get negative 5 over 16x squared plus, this would be 30 over 16, which gives us 15 over 8, x, and then this will be plus 35 over 16. Let's see if that reduces. No, we're good. So this is going to be our equation in standard form. So here's a little bit of a repeat. Example 1, a parabola has x-intercepts of -2, -8. Find the equation of the parabola in standard form if it passes through this point. So this is going to be xy, and then this is going to be rs. Okay, so we can't take two x-intercepts and plug them into standard form originally. So what we have to do is we have to find this equation in factored form first, and then convert it. So let's go ahead and sub in the x, the y, the r, and the s all in one line. So the y is -10, the x is -7, the r is -2, so it becomes a +2, the x is -7, and the s is -8, so it becomes +8. Okay, -7 plus 2 is -5, -7 plus 8 is 1. So we get -10 equals -5a, and then we just divide out. Okay, so our equation in factored form is y equals 2, x plus 2, x plus 8. Now let's convert. Okay, we want this in standard form. So we can go y equals 2, do the two brackets first, x squared plus 8x plus 2x plus 16. Let's collect the like terms in the middle. So 8x plus 2x is 10x. And now let's distribute the 2 into the bracket. 2x squared plus 20x plus 32. And this is our equation that has these two x-intercepts, goes to this point in standard form. Parabolic arc supports a bridge. The arc is 200 meters wide at its base and 4 meters tall in the middle. Okay, so when I'm reading this, I'm thinking immediately, okay, so we're going to have an arc, the height's going to be 4, and the base is going to be 200. Okay, so A, show the information on a graph by placing the vertex on the y-axis. So if the vertex is on the y-axis and it's 4 meters tall, we'll plot it here, so that the x-axis represents the base of the arc. Okay, so the x-axis is going to represent the base. So because it's 200 meters wide, that means 100 on the left and 100 on the right. So that's what it's going to look like. Okay, find the equation of the parabolic arc in factored form. So here's the thing. We have a point, 0, 4, and we have two x-intercepts, which are 100, 0, and -100, 0. So let's go ahead and put those all into the factored form of the quadratic relation. Okay, so we have 4 equals a, 0 minus 100. Okay, and then 0 plus 100. Okay, so 4 equals a, and then we have -100 times 100, which is -1, 2, 3, 4 zeros there. So -10,000. So we're going to divide both sides by -10,000. And we're going to get a equals, and this will simplify, 4 over 10,000, 1 over 2,500. Okay, so -1 over 2,500 will be our a value. So that's going to be y equals -1 over 2,500, x plus 100, x minus 100. And that's our factored form. Now the question, how high is the point on the arc? That is 20 meters horizontally from one end. Okay, so from this end here, 20 meters in would be at 80. So what we want to do is we want to take this equation, I'll do it in green, and we want to sub in 80. So y equals -1 over 2,500, 80 plus 100, and then 80 minus 100. So we're going to get 180 times negative 20. Okay, so 180 times negative 1 or negative 20, and we're going to go times negative 1 divided by 2500. I get 1.44. And let's just round it to that. So therefore, it is 1.44 meters high. And that's how we can use the equation that we find. 3. The path of a kickball can be defined by this equation here. Okay, where h is the height in meters above the ground and d is the horizontal distance. Okay, so we got height and then we have distance here. Okay, so find the d-intercepts. So what I would do first, all of these numbers here have a denominator of 35. So let's go ahead and common factor out the negative 1 over 35. See if that common factors. So then we're left with d squared. Then we're going to go 16 over 35 divided by negative 1 over 35. And we just get the negative 16. Okay, and then likewise with the 36 over 35, we're going to get negative 36. Now, what two numbers multiply to negative 36 and add to negative 16? Okay, so we'll go 136 to 18. That's it. Since 16, d is negative, we're going to put the negative on the 18. So then there's our factors. Okay, so d plus 2 and then d plus 2 and then d minus 18. Okay, so the d-intercepts are going to be d equals negative 2 and then d equals 18. And we can go ahead and, because there's a graph provided, I'm going to assume that we're going to graph it. Okay, sketch the graph of the relation using the d-intercepts and the vertex. So let's find the axis of symmetry. We're going to go negative, that's wrong, negative 2 plus 18, and then we're going to average it out, so divided by 2. So we're going to go 16 over 2, which is 8. That's right, that's wrong. Okay, so x equals 8 is going to be our axis of symmetry, and now we go ahead and sub in 8 into the equation. So h equals 1 over 35. I personally like doing the factored form. You can do the expanded form if you want. I don't want to write out all those fractions. Okay, so we got 10, and then 8 minus 18 is going to be negative 10. That's going to be 100 over 35. Okay, so if you put that into your calculator, you're going to get 2.9. Let's round it. Okay, 2.9. So on the axis of symmetry, we're going to graph 2.9. And we're all connected. Okay, so for what values of d is the relation valid? So what's the domain? So here's the thing, because we're talking about height and distance, okay, so it's only valid for from 0 until 18. And at 18 it falls back on the ground, so 0 to 18. So x goes from 0 to 18. Because we can't have a negative distance, and at 18 it falls on the ground. Okay, at what height was the ball kicked? So when it's asking this question, what it's actually asking for is the y-intercept. So that's when x equals 0. So if we went back to the equation, we would see that the equation is negative 1 over 35 d squared plus 16 over d, this is h, it's the h-intercept. 16 over 35d. and then plus 36 over 35. Okay, remember when we sub in 0, so we're going to do d equals 0. These two are going to go away, and we're going to get a height of this c value here. So that's when the ball was kicked. Okay, so therefore the ball was kicked at a height of 35 over 36. I mean, or 36 over 35, if you put it into your calculator, it's like 1.03. Okay, and how far had the ball traveled when it landed on the ground? Okay, so again, it goes from 0 all the way to 18. So therefore, it traveled a horizontal distance of 18 meters. Okay, example 4. Find the values of n so that this quadratic relation has only one zero. So we're going to go back to the discriminant, and the discriminant is b squared minus 4ac. So when we're solving for this, the a is 1, the b is n, and the c is 25. Okay, and in order for this to have only one zero, we need b squared minus 4ac to equal 0. Okay, because when you root 0, it only has one answer. So let's go n squared minus 4, 1, 25. And when does that equal 0? So we have n squared minus 100 equals 0. Let's bring that 100 over. N equals 100. We'll root both sides. N equals plus minus 10. Okay, and then let's graph the function. So because this is positive here, let's go with the positive. Okay, so we're going to have an equation of x squared plus 10x plus 25 equals 0. When we factor this, two numbers that multiply to 25 and add to 10 are going to be x plus 5 squared. Okay, so the x plus 5 squared, we're going to have a vertex because we have only one x-intercept, so that's going to be the vertex, and it's going to lie at -5. So now let's just use symmetry, okay? So let's plot a point at -3. Okay, so let's go -3 squared plus 10 times -3 plus 25. So this is 9 minus 30 plus 25. So we got 9 minus 30 plus 25, I get 4. Okay, so at -3, we're going to plot 4, and that means 2 units to the left, which is -5. We're also going to plot 4. And then we can go ahead and label this x squared plus 10x plus 25.